Hello, can you hear me? Hello? Can you hear me?
Yes, I can hear you, Professor.
Okay, how are you doing?
Good, how are you?
Fine, thank you. Yeah, I wanted to do this for last week. I want to do this lecture, practice lecture today about probability distribution and conditional probability. And of course, this week, what we have this week is sampling distribution. So I'm going to do another video for that and then put it in the class so that you can watch it before you do the midterm exam that is coming. So I'm going to do a series of videos.
Okay, perfect.
For probability and probability distributions. We are not able. Let me see. I'm trying to see where I clicked last. Okay, I'm back here. Yeah, this thing's give me 1 minute. Let me get this thing right. There's something I'm missing. Okay. Yeah, I think I got it. Can you see my screen? What I have on the screen?
Yes.
I can see it.
Okay, good. So now maybe I will do another video on that introduces probability, but I got some questions from this topic last week, so that's why I want to start from here. And of course, I'm going to do more. It might not be a session like this, but I will do the video and post it in the class so you can watch it, post in the announcement before you do the midterm exam next week. Now, for what we have this week, which is samples and sampling distribution, by Sunday night, I'll do a video on that and also post it so you can watch it, that video. Okay, so now I think we can begin now. Okay. So the topic is conditional probability Bayes theorem. Then we take a look at probability distribution, what they are, and we work on 3 of them. I think I'm missing one, which is normal distribution. Normal distribution. I will work on normal distribution here as well. Okay. These are the three different types of probability distribution that we are covered in this course: binomial, Poisson, and normal. So we'll be taking a look at those as well. And where it will require us to use Excel, I will use Excel. Where it requires us to just do the work, I'll also do the work solving. And I want to also to use this opportunity to show you this online calculator. It's a scientific calculator and it's free online. It's called desmos.com/scientific. I guess you can see it here. See, it is free. Once you type this desmos.com/scientific, it will give you this scientific calculator. So any question you are solving that requires a calculator, you can use this or your own calculator. Then those that require Excel, you can use Excel. I also opened an Excel. I think I opened too many pages. This is an Excel that I opened that we'll be using. I'm going to open a new folder for that. Okay, good. Now let's begin. Starting with conditional probability. The conditional probability, like I wrote on the screen, it tells us, it measures the likelihood that an event will occur, given that another event have already occurred. For example, having good grades and getting a scholarship. The condition for getting the scholarship is that you have good grades. That qualifies you for the scholarship. So the conditional probability there is getting the scholarship, given that you already have good grades. Now, we have it in different areas. For example, getting a job, if A is the probability of getting a job, and B is the probability of that you have a degree. Therefore, the conditional probability of A given B is A and B divided by B. Probability of A and B divided by the probability of B. So, probability of getting the job, given that you already have a degree. See, given is the condition. And normally we use this forward slash to show that given. Forward slash. Let's see it right here. See the forward slash. You can see right here. That is how you know that it is a conditional probability. When they say given. So now let us take a quick look at some of these examples. It says here, the test result for marijuana use is presented here. Before I solve this, does anybody have a question for me on what I said earlier about conditional probability?
No.
No, but you can still see the screen though, right?
Yes.
Okay, good. Now, it says the test result for marijuana use is presented on this table below. And this is the result. Does the subject actually use marijuana? This is the result. Positive results and then negative results. Okay, positive result means that the subject tested positive for marijuana. Negative result is that it tested negative. And these are the numbers, and they get the totals at the end. It said, choose one subject at random. Find these probabilities. The subject tested positive, given that he or she actually uses marijuana. The subject actually uses marijuana, given that he or she tested positive. The subject tested negative, given that he or she uses marijuana. So this kind of thing, best thing is to do is to get the totals, and they gave them to us already here. Then you identify the outcomes that you're looking for. For example, I'm using M for marijuana, P for positive results, and then I'm gonna use N. These are the outcomes I'm looking for. N for negative results. Excuse me, sorry. Negative results. And of course, M for marijuana, P for positive results, and then N for negative results. Good. Now, let's see. The first one says, the subject tested positive, given that he or she uses marijuana. So I'm gonna show you. This workbook won't allow me to get the formula the way it is. So I'm gonna put it right here. The subject, you're looking for the subject tested positive. P. Make sure you're seeing this. Okay, the subject tested positive. Okay, positive. I'm gonna make it to be bigger. Make it bigger, 18 at least. Positive. The probability that it tested positive, given that he or she uses marijuana. Okay. Oh, I know why I did that. I'll fix it now. Tested positive, given that they use marijuana. Okay. Equals, we have positive, probability of positive and marijuana use. Okay, divided by probability that they tested that they uses marijuana. See, that's the formula we need. If you remember the question says here that the subject tested positive, given that he or she uses marijuana. So positive is P, given that he uses M. So that's the formula we have here. Okay, you can see it right there. So equals, let's put the numbers in. You will see I will have here say that this is the positive result right here. The whole of this row are for positive results. And uses marijuana is yes. So see positive and yes uses marijuana. You can see that they're intersected here. You know, think of it as the road intersection. You know this, the intersection in the road. So that's the same thing here. Yes and positive, they intersected here, which is 119. Okay, 119, you're going to put 119 there. 119. 119 divided by the probability that he or she uses marijuana, which is M. And that for that probability, we use the total for that they use is yes, they use it, see? Yes. And the total for that is 122. 122. So I put 122 right there. 122. So now this we can put in the calculator. Let me write this down on paper, and then we can put it in a calculator. I'll write it on this paper. Yep. 119 over 122. So taking you to the calculator, you can see 119 divided by 122. 0.975. 0.975. So we got 0.975. 0.975. Or if you like, you can call it 97.5% chance that the subject tested positive, given that he or she uses marijuana. So I'm going to copy this and put it in our main workbook, which is where the equation is located. Part A is right here. So you can see that. See? P and M, which is positive results, then yes, uses marijuana. See the intersection 119. You can see right here, 119. Then over the probability of marijuana, actually number of points marijuana, you can see all the marijuana use. Does the subject uses marijuana? Yes. And the total for that is 122. You can see right here, 122. 19.7. So any question on this?
Not at the moment, no.
Okay, so this is how conditional probability works. Many things we do in life actually is conditional, and that's we recognize it there. So the formula is to get the joint occurrence of that event divided by the probability of the condition that was given. Let's try another one. It says the subject actually uses marijuana given that he or she tested positive. In this case, we are looking for this is part B. The subject uses marijuana, which means we're looking for probability of M, given that they tested positive, P. So because this page will not allow us to put the formula in this form, so I'm going to take you to that page again and write it down. Probability of M, PM, given positive. So let's go and write it down in that place, and then we can put the numbers in. We got uses marijuana care, given that they tested positive. Okay. So you got marijuana and positive, M and P. This time around, the condition is positive, is P. So we're gonna put the condition right here. Okay. So we're gonna erase all this. So we can put our answers, the correct answers in. Okay. Now let's look at the table to get our answer. From the table, we have that it says here actually uses marijuana, given that he or she tested positive. Yes, is that they use marijuana. They use marijuana is yes. The whole of this column, yes. Given that they tested positive. Positive again. So they intersect here again, which is 119. So I'm going to go there and put 119 for that. 119. But this time around, say the condition is that they tested positive. So I'm going to be looking at the positive results. See, all these numbers on this row are positive results, and the total for that is 143. So you're going to be 143, 143. So that would be 119 divided by 143. So I'm taking you to the calculator. You have divided by 143 this time. 0.832. 0.832. So I'm going to put it right there. 0.832. Or if you like, you can call it 83.2% chance that the subject uses marijuana, given that they tested positive. So I'm going to copy this and then paste it right here. For the second part B, I'm going to paste it right here. By the way, do you guys want me to upload a copy of this video for you after it's over?
Yes, that would be fine.
Okay, I'll do that, sir. Then part C says the subject tested negative, given that he or she uses marijuana. That can happen. Somebody might be using it, maybe because of their body chemistry, they still tested negative, or because somebody made an error. We call it false negatives. So in that case, we are looking for that probability that they tested negative, given that they uses marijuana. That's what I'm going to put. So as you can see, because this workbook won't allow us to put the formula, I'm going to take you to that other workbook, our second workbook. Tested negative, given that they use it. Okay. I change to N, and they use marijuana. So they tested, it's going to be pure negative and uses divided by the probability that they use. But yet they tested negative. So I'm going to erase all this. I'm going to erase them so that we can put our correct number. So negative and tested negative and uses marijuana. So we can get it from the table here. Negative. Okay, look at negative results here. Negative, whole of this column, row, and the uses, which is yes. It's 3. So negative result and uses, the intersection is 3. Number 3 is the intersection. So 3, at the top, we have 3, which is 3 here, divided by the probability that they use marijuana. Then for uses marijuana, you can see it right here. Yes, again, which is this column, 1, 2, 2. Okay, 1, 2, 2. 122. And so 3 divided by 122. So you have in the calculator 3. 3 divided by 122. Give me 0.025. 0.025. 0.025. Or if you like, since this is a probability, it can be percent, or 2.5% chance. So the chance that this can happen is very slim, just like the chance of every false negative happening is slim as well. So I'm gonna put it right here, 2.5% chance. So that's how you do it, the conditional probability of an event occurring. And I'll solve more examples of that so that that idea of conditional probability can register in your mind. Before I solve the next question, which is number 2, anybody have a question on this?
No, not so far.
Okay, good. So now let us look at another way it might occur. It might ask the question. It says 2 cards are selected in a sequence from its standard deck of 52 cards. Find the probability that the second card is a queen, given that the first card is a king. assume that the king was not replaced. So first thing is that, actually this is a type of classical probability. I haven't done a video on introduction to probability, but we have done it. I mean, that was the week before last week, I believe. But I posted videos for you to watch before, for that. That was it for the second quiz, I think. So anyway, classical probability, in that case, for classical probability, we determine the probability of events by using the sample spaces. I mean, sample spaces mean all the possible outcome of any probability experiment. For example, for the deck of cards, this is the sample space right here, 32 cards of different suits and them. Now, for king, it says, find the probability that the second card, I mean, if you select two cards, you select one card, then before you select the second card. So if suppose that is what happened, I mean, in a fair game, it says find the probability that the second card is a queen, given that the first card is a king. Assume that the king was not that the king was not replaced, or that the card was not replaced. They put it that way. Now, let's identify our outcome: Q for queen and K for king. So we're looking for the probability that the second card is a queen, given that the first card is a king. Okay. Now, if you look at this, before you made the selection, there are 52 cards, and we have 4 kings and 4 queens. Before you make the selection, there are 4 kings and 4 queens, and the card total was 52 cards. So for queen, we have 4 queens, and for king, we have 4 kings. So now that the first card is a queen, given that the second card second card is a queen, given that the first card is a king. So by the time you make your first selection, it's 4 kings. Then you made the selection. This time you do not replace it. So now we have 3 kings left for a total of 51 cards left, since you do not replace it. Now you want to make the selection for queen. So in that case, we still have 4 queens because we didn't select it yet. But now a total of 51 cards, since we did not replace the king. So that means 4 queen out of now 51 cards. And that will give you your answer right there. 4 over 51. 4 divided by 51. You have 0.078. 0.078. So I think that's what I got, right? 0.078. Yep. 0.078. Yeah. If you like, I can call it as 7.8% chance that the second card is a queen, given that the first card is a king. Questions?
Yeah. Not at the moment, no.
Okay, good. Now it might be in this form where they give you. Remember the one we saw before with a table. This one here. They give us the numbers. They didn't give us the probability, so we have to figure out the probabilities by ourselves. But this type here, I think this is similar to the question that somebody asked me. This is a type where we have you know what, I'm gonna move it to the next page so we can have enough room there. See, look at this one. It says, given the partial relative frequency table here, it says, suppose one person is selected at random. Find these probabilities. Say compute P, probability of Democrat, given that the person is a male, and enter your answer in 3 decimal places. Compute the probability that the person is a Democrat, given that he or she is a female. Sorry, given that she's a female. So this is the kind of question they might ask it in this form. So what do you do? Now, the good news is that they already gave you the probabilities, so you don't need to get totals anymore on the left Coleman rules. So for this, you can now do Give me one. Let me see what I have here. Oh, I think I have something else here. Not something different here. Anyway, part A, solutions. We are looking for the probability of that male. Let's identify our outcomes. Let us use M for male, F for female. Okay, R for Republican, then D for Democrats. Okay, I for independent. Yeah, the first question says, find the probability that the person selected is a Democrat, given that he's male. So we're looking for the part A says probability of Democrat, that's D, given that he is a male. Now, again, since this section will not allow us to put the formula, I'm going to take it to that other page. So we're looking for the probability of Democrat given male equal. So let's go and put the formula there. We're looking for the probability of that this person is a Democrat, given that he's male. So we're going to use probability of Democrat and male divided by probability of male. So I'm going to clean the rest of this. Democrat and male. So the probabilities are they're already given to us. Look at what represents Democrat and male. Okay, this is Democrats. This is male. They intersect here. Just Democrat and male, male and Democrat. See? And so I mean 0.230, 0.230 divided by the probability of male. Okay. And the probability of male will be this is all males here. See? It means this plus that. These two numbers. There's three numbers. One, all that. See, if you go this way, all the columns that sorry, all the rows. This is the male. This is male. So let me write this down. 0.150 plus 0.230 plus 0.170. These are the all that represent males. So we go down and put them in. The probability of males, okay, 0.150, okay, plus 0.230 plus 0.170. Now, to simplify it, you might even want to maybe get the total from here. So that, in fact, let me, yes, can add the total from here, add this and write total. But I didn't do it because, remember, we didn't have a number for the independence. That's why I left it like that. So that will give us the answer we are looking for. So let us work this out. I'm going to write this on my paper, and then we can put it on the calculator. 0.230 over 0.150 plus 0.230 plus 0.170. Okay. Now let us go and put this in a calculator. Okay. So we got 0.230 divided by 0.150 plus 0.230. Oh, excuse me. 230 plus 0.170. 0.418. let me put parentheses there, make sure that everything looks good. Okay. Oh, I put it this one. So 0.418. Yeah. 0.418. So you got 0.418. So I'm gonna copy this and put it on in our main workbook. So that is right here. I'm gonna put right here. So okay, see. Now next one is the compute the probability that the person is the Democrat, given that it's a female. As part B. Excuse me. The probability that is a Democrat, given that it's a female. Democrat, given that it's a female. Now, let us put the formula first, and then we'll come back and show you, because this one is a tricky, since we don't have the answer for the independent part of it, which we need. So let us, let me go ahead and put the formula ready, get the formula ready first. Say Democrat, given that he or she is a female. Democrat given female equals, let's go and put the formula together first. Probability of Democrat giving female. It means probability of Democrat and female, and the condition that she is female. Now I'm gonna erase all this, and erase this. Okay, now let's so to have to figure out what is in this, what will be here. Now you know that one of the rules of probability is that total probability of all the sample space equals 1. So that to get the answer for this, you add all these probabilities and subtract it from 1 to get this one, because the probability of the sample space is 1. So let's do it again that first. Let's get for the independence I, P for independent female. Independent and is female will be equal to 1 minus. Now you can now add all these probabilities. I wrote it down somewhere. I think I wrote it down somewhere. Because I think I have it written down here. Yep, I got it. I got it here. So 1 minus. So you're gonna subtract all this from 1. So I have 1 minus 0.150, which is the first one from here. Okay. Plus 0.120, which is the second one here. So you continue like that until you get to the last one. Okay. Plus 0.230 plus 0.200 plus 0.170. Okay, I got 1, 2, 3, 4, 5, and the 1, 2, 3, 4, 5. Okay, good. So we can now get this answer from the calculator. We have taking you to the calculator. That is 1 minus 0.150 plus 0.120 plus 0.230 plus 0.200 plus 0.170 plus it 0.13, 2.13. So you got that one 0.13, 0.13. So that means that the number that will be here will be 0.13. See? 0.13. That number that will be here. With that now, we can now find the probability that the person is a Democrat, given that is a female. So you can see female Democrat, see Democrat given female, they intersected here. They intersected there, 3.200. So you're gonna go there and put 0.200. Oh, excuse me, sorry. Taking you to where we have our formula. 0.200 divided by the probability of female. For that, you can get that from here, from the table. You add this, and that to get the probability for female. So I'm going to write it down here so I can put them in. 0.200, right? Divided by 0.120 plus 0.200 plus 0.130. So let's go and put them in. So we got 0.120 plus 0.200, excuse me, 200 plus 0.130. And that will give us the answer we are looking for that question. Let's put it on the calculator. So you have 0.200 divided by 0.120 plus 0.200 plus 0.130. 0.444, which is 0.444 or 44.4%. So make it a little bit smaller because it's taking all the spaces. Copy this and paste it on our main workbook. Okay. Right, it is right here. Any question on this?
No, that was actually a good demonstration because that was one of the questions I was confused on.
Oh, this is one of them, right?
Yes. I forgot to put the independent instead.
Somebody asked me that, so I made up a question that looks like that, and then solved it as a sample for him to use as a guide, So that's why I decided to do it here again. Yes. Now, that's basically what a conditional probability is about. Now we can now look at Bayes probability. Bayes probability is actually a type of conditional probability. In that case, we have said our goal is to find the probability of A given B from the information about B, probability of B given A. So we use it, I think they use it a lot in genetics too. Yeah. It's a very popular type of conditional probability. And the formula is, don't mind the formula, they might look like monster, right? But when you start using them, you see that they're actually not that bad. So just once you get the concept and start using it, see, this is how the formula looks like. So I'm going to break it down for you. Probability of event AI given B equals the probability of B given AI times probability of AI, then divided by, now you start from the first one and do the same thing for AI, do the same thing for A2, actually A1, do the same thing for A2 and A3, and continue until you get to the last number of A, where the A part represents the event of interest from a choice of n event. Then the B part of it is an event that have already occurred. Okay. So let's look at this example here. It says, I make it a little bit bigger. Yep. So this is a book club. Can you see the screen very well?
Yes, I can see it.
Good. It says here, a book club, look at, give me one, let me get some, something I'm looking for here. What is it? Oh, I think I got it. I closed it. Yeah, I have something that looks like that here. And I close it. Okay. Said a book club, oh, excuse me. A book club classify members as heavy, medium, or light purchasers. And separate mailings are prepared for each of these groups. Overall, 20% of the members are heavy purchasers, 30% of them are medium, and then 50% are light purchasers. A member is not classified into a group until 18 months after joining the club, but a test is made of the feasibility of using 3 months, the first 3 months of purchases to classify the members. And we have the following results. For the first 3 months, heavy purchasers, medium purchasers, light purchasers. And how many books they purchased? First 3 months purchased. No book, one no book purchased, 1 book purchased, 2 books, then 3 plus purchases. So if a member purchases no books in the first 3 months, what is the probability that the members is a light purchaser? Now see, remember that I said that A, B is an event that already occurred. So we have them, they give us already here. Overall, 20% are heavy purchasers, 30 are medium, and 50 are light. So these are based on previous purchases. So that will give us that with that, and then they give us this current purchase for the first 3 months here. They say if the member purchases no book in the first 3 months, what is the probability that the member is a light purchaser? So let us solve it by first of all identifying the outcomes we are looking for. So suppose that we have a use solution. We have L for light purchaser. Okay, light purchaser. Excuse me. Yeah, M for medium purchaser. Okay, so okay. Then what's the other one is heavy purchaser. So H for heavy purchaser. Okay. Now, you said, but the question was, if a member purchases no books, that means you can use 0 for no book was purchased. No book was purchased in the first 3 months purchased. Because it says, if a member purchases no book in the first 3 months, what is the probability that the member is a light purchaser? So what we're looking for here is actually the probability of, excuse me, sorry, probability of the light purchaser, right? L, given that member is bought no book, right? The probability of light purchaser, given that they did not buy any book. Now, because this page will not allow us to put this in, I'm going to get the formula from the other workbook. Remember, let me write this down. The probability of light purchaser, given that he bought no book. Let's go and put it over there. Light purchaser, light purchase. Okay. L. Oh, this one is gonna be a different type. For this condition, they give us a priori probability. So probability of, okay, light purchaser, okay, light, given that the purchases no book, okay, equal. So we're gonna have it this way. The point that no book was purchased, probability of no book was purchased, given that is a light purchaser. Oops, excuse me, sorry, my mistake. I didn't put it right. No book was purchased, right? Okay. given that it's a light purchaser. Mistake. No book was purchased. 0, given that it's a light purchaser. Okay. Times probability, and the probability of that is a light purchaser. What is the times we're gonna use this time, right? Times probability of that's a light purchaser. Okay, light purchase. Now remember, we have in our sample the information we are giving the probability for all type of purchases for the medium, heavy, and light. So you're gonna repeat the process for all of them. Okay, so you have all everything divided by, starting from the first light purchase, you have probability of 0 purchase. Okay, 0 purchase, okay, 0 purchase. Put this right here. 0 purchase, given that, keep putting this wrong way. All right, 0 purchase, given that it's a light purchaser, okay, times the probability of this light purchase, which is this light purchase. So to make it, let's see if I can make it faster by copying this and then, oops, undo. Okay, copy. Now, plus the probability of 0 given medium purchaser times the probability of medium purchase. Okay, plus repeat it for all the type of purchasers. Probability of 0 purchase given have that is a heavy purchaser, right? Heavy purchase times the probability of heavy purchase. So you multiply it by the prior probabilities. Now, when I say prior probability, I'm talking about this one here. What we know already. They say that overall, 20% is a heavy purchase, 30 is a medium purchase, and 50 light. So you multiply the probability of 0 purchase with all these type of purchases, and then you get your answer. So let's put the numbers in. For this one, for this part here, the first one, 0 given light purchase. We look at the table. You can see 0 book, 0 given light purchase. Light purchase is 60%, which is 0.6. So I'm going to write it down. 0.60 times. You look at the formula again. Times the probability of light purchase, which is this one here. Light purchase, which is given in the question. For light purchase, we have say 50 are light purchase, 50% are light purchase. So 0.50 multiply by 0.50 divided by, now repeat it at the denominator. You can repeat it at the denominator here, because this is something here. Probability of 0 given light times P of L. Then you have it here, P0 given L times P of L. So you repeat what you have here on this side. So I'm going to write it down, then I'll put it on the screen for you to see. So we have 0.60 times 0.50 plus. Now, next one to put is for the medium purchaser. You see, I'm giving medium, 0 giving medium, right? 0 giving medium. That's no purchase, given that is a medium purchaser, is from the table we have no purchase, no book purchase is 0, given that is a medium. See, 0 and medium, see, they intersect here 15%. I mean 0.15 times the probability of medium, which is this one here, and it is given on the equation, which is for medium, we have that 30% of them are medium purchasers. See, so 0.30 plus Now, for the last one, which is the heavy purchasers, as you can see from the formula here, for heavy purchasers, we have zero, probability of zero giving heavy, zero giving heavy. You can get that from the table here. See, no purchase given that it is heavy. It's right here, 5% is 0.05 times the probability of heavy purchasers, which is given on the body of the question as, say, overall 20% members are heavy purchasers. So it's 0.20. Okay. So now what I'm going to do now is to put the formula here and then put the work here. So let me first of all put the formula in so you can see how it looks like. Okay. So I'm going to put it right there. Share it with you. So this is how the formula will look like. So I've started putting numbers in now. So let's put the numbers in. Okay. Based on what I just explained, I'll put numbers in. So you have 0.60, okay, times 0.50. Then here we have the same thing because it's still the same formula term here, 0.60 time. I'm going to put parentheses so that it will follow order of operation. Time, excuse me, times 0.50, okay, plus this one is 0 given medium. We have that as here for 0, no purchase, giving medium as 0.15 times the probability of medium, which is 30%, which is 0.30 for the medium. Okay, so we have it here as we have this as for medium, we have 0.15, okay, times 0.30. Okay. All right. And then next one will be plus for the heavy, which is 0 given heavy. This you can, like I said, we have it here. No purchase given heavy is 5%, right? It means 0.05 times the probability of heavy. This is for heavy here, 20% are heavy purchasers. So 0.05 times 0.20 for heavy. So you have 0.05 0.05 times the heavy purchasers, which is the probability they give us for that is 20%, which is 0.20. 0.20. So that will give us answer that we get from now. Let me make it 16 so that we can have enough room for the answer. So now let's put it on the calculator. You go to our calculator, we have this. We have the 0.60 actually, yeah. So 60 times 2.50 divided by 0.60 times 0.50. Okay, I've already listed them for you, so I'm just putting them in. Plus 0.15 times 0.30 plus the last one for the heavy purchasers, 0.05 times 0.20, 0.845, 0.845, 0.845, 0.845, and that is the probability for that. 0.845, that's the answer we are looking for. 0.845. Any question on this? Any question?
No, not so far. Just a lot to input, but so far so good.
Okay. Now we can try this as a practice when you have the chance. Let's go to next thing we have, which is the probability distributions. For that, let me take it. Just give me 1 minute. Let me use the restroom. I'll be right back in a minute. Okay.
No problem.
Okay.
Right back now. Yeah, I'm back. So, hello, can you hear me? Are you still there?
Yes.
Okay, sorry about that. I take this. Now, probability distributions. Let's start with the basic concept, random variable. A random variable, we say that a variable is a random variable when the values are determined by chance. So, for example, in a dice, when you toss a dice can land on one. When it lands, one will be showing up, or it can be two showing up. It can be 3, 4, 5, 6 showing up, showing on the dice. So it's random. The number of siblings any student in a campus can have, to you, is random, because anybody can have any number of children they have. How about the arrival time of a bus at a bus station? I mean, sometimes they write the time the bus will arrive. They say that they wrote that it will arrive at 9 o'clock. Sometimes it comes by 9 o'clock, sometimes 9:15, sometimes 8:99, sorry, 8:59. So it's a random thing. So now, but discrete random variables are those they assume numbers that can be counted. They assume values that we can count. For example, number of people jogging in the park, can say that one person is jogging in the park, or 2, or even 10. But you cannot say that it's 1.5 people, because you don't count 1.5 people. So discrete random variable assume that value that we can count. Number of eggs a hen lays in a week. 1 egg, 2 eggs, 3 eggs. You can't say 1.5 eggs. You can count it. Number of telephone calls that you receive after a TV commercial. These are discrete random variables because they assume values that we can count. But continuous random variables don't have values that are measured. Things like height, temperature, voltage. So when we talk about probability distribution, we are looking at continuous probability distribution and discrete. What I'm trying to say here is that we have the discrete type and the continuous type. For the discrete type, we'll be looking at binomial distribution and Poisson distribution for this class. And for the continuous type of probability distribution, we're looking at only the normal distribution. Let's start with the binomial. Now, binomial experiments, let me start with binomial experiments, because that's where once you start to understand it from there, then everything looks more clear to you. Now, there are some problems that when I say problem, I mean the probability problems that have 2 outcomes, or outcomes that we can simplify into 2. For example, when you toss a coin, the coin lands head or tail. 2 outcomes. In a basketball game, no matter how many goals they score, it is either the team wins or they lose. 2 outcomes. When a baby is born, it's either male or female. 2 outcomes. Blood pressure, no matter what number it is showing, it is either it is normal or it is not normal. 2 outcomes. So all these kind of variables can be modeled using binomial, because they result to 2 outcomes, or outcomes we can reduce to 2. So this all the scenarios that I just described, 4 of them are examples of binomial experiments. Now look at the properties of the binomial experiments. Each trial can have only 2 outcomes, which I have explained with examples, or can have outcomes that can be reduced to 2. There must be a fixed number of trials, and the outcome of each trial are independent of each other. Then the probability of success must remain the same for each trial. When I say success here, it depends on what the outcome you're looking for. So if the outcome you're looking for is the number of students who miss class, that means your success probability is the probability of those who missed classes, and so on and so forth. So for a dice have 6 sides. So for the dice, px is 1 out of 6. And for coin, for example, success is one out of 2 because a coin have 2 sides, 1 out of 2. That will give you an idea of what I'm talking about here. Now, the binomial distribution. So all the outcomes of the binomial experiment and their corresponding probabilities are called the binomial distribution. All the outcomes and their corresponding probabilities is what we call the binomial distribution. Normally, we use these terms: p, small p for the probability of success, q for the probability of failure, which we always get by this formula. Q is always 1 minus p. N is represent the number of trials, and x is number of success in n trials. So for the binomial formula, we use this: PS equals n combination x times p to the power x times q to the power n minus x for all the s values that start from 0 to n. Now, like I said, the formula might look like a monster, but remember we'll be using Excel for some of them. So for example, this one we'll be using Excel, so it should be good. Let's see how this works. It says in this question, let me go down here. It says find this probability. Find the probability that a 5 occurs. Sorry, my mistake. Find the probability that in 5 tosses of a fair dice, a 3 appears at no time, once, twice, 3 times, 4 times. Okay. So what I'm gonna do is to make it simple for us. Let's find the n here. How many times was the coin tossed? It was tossed 5 times. So our n is 5. For our p, which is the probability of success, for the dice, is, remember I explained it here, that is 1 out of 6 chances for any of the outcomes. But this one, it says was tossed 5. Okay. A 3, so p is 1 out of 6. Here. And q is 1 minus that. 1 out of 6 will be equals 1. Let's do it and get it from the calculator. 1 out of 6. Anyway, in any case, we get it from the using Excel. So in other words, let us just put this in Excel and get everything out. I'm going to write them out so we can put it in Excel. So to make it less complicated. So I usually like to get all if I'm doing binomial in Excel, I usually get all the answers for everything, then choose the one I need for that particular question. So, but our n it was tossed 5 times. So that in Excel we have that. Oh, excuse me, Excel is right here. Let me make it bigger. So you have n. N equals, so we have it was tossed 5 times. And p is 1 over 6, right? Because for the dice is 1 out of 6 chances. So it put equal sign and do 1 divided by 6. Then press the enter key to give you the results here. And then Q, I don't think, maybe we may not even use all this, but let's say Q equals, for Q, if you look at the formula for Q here, in the what I have on the equation, when I was introducing it, say Q is 1 minus P, always 1 minus P. So we got we have 1 minus P in our Excel. 1 minus another P is this right here. So I'm gonna press this here, get it. Now we're ready to answer these questions. So we have our X. Okay, when I say X, number of times see, S represents, if you look at here, it says number of success in n trials. So he said that it was tossed 5 times. So we are looking for the probability that a trait occurs at no time once, twice, 3 times, 4 times. Okay. So we have it in this form, and we say have 1, 0, 1, 2, 3, 4, 5. Say 5 times. Let me check it again. 5 times, right? Once at no time, once, twice, 3 times. Okay, 4 times. Okay, 4 times. Well, I'm just 5 times. Nothing wrong with that. So we can now get our Excel formula in for binomial, and then put these numbers. And so these are the required probability px. Px. Okay. Required probabilities. Okay. Are you ready for us to do it? Hello?
Yes.
Okay. So now the formula right here, put equals and type binom dot dist. Okay, once I put it, it will show up. Double click on it. Oh, excuse me. Equals binom dot this, so it pops out. Then double click on it. Then you can see that it has number of trials. Okay. Then we have the trials, the probability of S, and then the success probability, then cumulative. So we have I don't think I need cumulative. So this should be okay. Well, the number of trials was tries 5 times 5 times, type 5, comma, then for the trials, oh, actually numbers. Okay, sorry, my mistake. For numbers, click on this 0 here, comma. Then for the how many times number of tries 5, comma. Probability of success is this one here. Click on that. I can just use that. That's not what it is. Then true. I don't want true because I want individual probability. If we say true, that means it will add, it will be cumulative. So I just type false. So it will give me the individual probability for each trial. See? Once you do that, then you can just do it for the first one. You can just copy it down. You give me oh, I know why. I know why. I know why it's doing this. So just give me, I'm gonna fix it now. Okay, let's do it again. Equal, because if I want to use this, I'm gonna put this. I'm gonna I forgot the right term they use to freeze it. Anyway, say binom dot dist. Okay. Now number of trials have numbers here, comma. Trials 5 times, comma. Probability, let me just type it in 0.16667, comma. True. I don't want cumulative. So I just want it I want it to calculate for individual probability for 0, 1, 2, 3. So I'm gonna type false so that you're gonna use probability mass function. False. Okay. Then I can just copy it down to calculate the rest of them. See? So now with this, you can answer the question. The first one says the probability that they appear at no time is right here. When it is there, it is 0. This is A at no time. This B appeared once. C appeared 3 times. D appeared 4 times, right? Okay, 0, 1, 2, 3. So 3. Then F is appeared 4 times. But that's what he asked us, right? Yeah, that's what he asked us there. Yep, up to E. appeared 4 times. You can see the individual probabilities right there. So you can, like I say, if I click on it, I can see the work. So when I'm grading it, I'm going to see the work done when I click on each answer. Okay. Any question on this? Any question? You still there?
No. Yeah, I was trying to do it myself on my Excel, but
Oh, okay.
yeah, no questions so far. I'm just following along.
Yeah, I'm gonna post it in the announce. You guys read my announcements though, right?
Yes.
Okay.
Yes.
So I'm gonna post this video on the announcement after we
Right. I
finish.
just like to practice too, just
Yeah,
because
it's
I go
good.
back to the video and then I forget what happened.
Yeah. So that's basically what it is. Like this one here, it says, this one is more direct. They want you to get only one answer for this one. I want to show you the formula and then show you if you want to use Excel, how you're gonna work. It says here, it is claimed that a particular flu shot, you know what, let me move it down so we have enough room for this. Yep, right here. It is claimed that a particular flu shot is effective 70% of the time, effective in 70% of the cases. If a group of 15 adults receive the flu shot, find the probability that exactly 10 will benefit. Now look at this. It says, how do you know it's a binomial? Because there's only 2 outcomes. Either it's effective or it is not. So that's its 2 outcomes. So it says, find the probability that exactly 10 will benefit. So how many people if a group of 15 receive it, so how many people receive it? 15. So N is 15. And P said that it's effective 70% of the time. That means P is 70%, which is 0.770. Then Q is 1 minus P, which is 1 minus 0.7. That will give us 0.3. So we're looking for the probability that's exactly 10. So our X is 10. See, unlike this one, we have different X's. We have the X for it appeared once, which is X is 0. Here S is 1. Here S is 2. But here they're asking me for only one X, one X. So if you can plug it in here, they're looking at probability of 10, that it is exactly 10 benefit from the shot, from the flu shot. Yeah. Okay, we'll do this way. Will be equals to N combination X, which is N. Our N is 15. So you got 15 combination X10 times. Now let me adjust this a little bit. Okay, 15 combination 10. 15 combination 10. Okay, times P to the power X. And P is 0.7. 0.70 raised to the power X, and S is 10 times. Adjust this. Oh, excuse me. Control. Okay. Times Q to the power N minus X. Q, which is 0.3. Q is 0.3. 0.30 raised to the power N minus X, and our N is 15. 15 minus S is 10. And that will give us the answer we are looking for. Okay. Putting this in the calculator, we have, let me write it down and then we can put it on the calculator. And then I will show you how you can do it with Excel. The same process, 15 combination 10 times 0.70 raised to the power 10 times 0.30 raised to the power 15 minus 10. So putting this on the calculator, we have, this is my calculator here. Okay, for the combination, just go to the function. You can see NCR right here. Okay, 15 combination 10. I'm talking about this, I'm talking about this part. We have 15. Okay, let me make it bigger so you can see it properly. See, 15 combination 10. So you can get it from the calculator from right here. See, see right there, NCR. 15, 15, comma, 10. Okay, I'll give you an answer right away. Then it says that we multiply it by times 0.7 to the power 10. Okay, I have times 0.70 raised to the power 10. Okay, times, next is this one, what that says 0.3 to the power 15 minus 10. 15 minus 10 is 5. So that means 0.3 to the power 5. 0.30 raised to the power 5. Okay. Because 15 minus 10 is 5. Am I right? Yeah, 15 minus 10 is 5. Yep. And that gives us the answer right away. At 0.206. 0.206. That's 0.206. 0.206. See? And that's it from the calculator. If you want to do it with Excel, then we need to enter these numbers. Let me write them down. N is 15 and P is 70. That is 0.7. And our X is 10. So I can take it to the calculator. I'm sorry, to the Excel, and we can get our results right away. In that case, our N equal to 15. Okay. P equal to 0.7. Okay, then I have our X, which is what I'm looking for, equals, we have 10. So we're looking for this problem, the P that only exactly 10 people benefit from it. Okay, will be equal binom dot dist. It will pop out, double click, then type numbers, 10. How many trials? N is 15 trials, comma, probability is 0.7. Okay. We are looking for the mass function, so we're gonna use false. Okay, and that gives us the answer right there. 0.206, you can see right there, 206. Which is the same thing that we got here. 206. 0.206. You have a question on this one?
No, Professor.
Okay, good. Now, sometimes they can ask you the question in a different form. I want to show you another form they will ask it. And then we can now conclude that section with mean, variance, and standard deviation of that. And then we can go to Poisson distribution. We're almost done. Once we finish Poisson distribution, do normal distribution, we are done for this. Then I'm gonna make another video by Sunday night for the what you are doing this week. So that I want to do is before you do the quiz for the week, so you can now watch it. And I'm gonna do more before next week so that you will do your midterm, so you can watch these videos. Since we cannot, the only time we come to the campus again, it will be on July. So I want to have several of them done for you. Look at this.
Sounds good.
So, you said something. What was that?
Oh, saying it sounds good.
Oh, okay. Sure. I say here, a survey found that 45% of teenage consumers receive their spending money from part-time jobs. Yeah. If 6 teenagers are selected at random, find the probability that at least 3 of them will have a part-time job. See, this is the key word here, at least 3. I want you to take note of this. At least 3. Give me a minute. Just 1 minute. Father. Yeah, good evening. How much you guys? I don't know my class remotely. Okay, sorry. No problem. How much you guys? All right, sorry about that. Now we have at least if you say that 6 we are selected, when you say at least 3, it means 3 or more. See? So anyway, how many teenagers were selected? It says 6 of them, N is 6. P is 45%, which is 45%, which is 0.45. And X. Now it says find the probability that at least 3. So S means 3, 4, 5, and 6. Now, if it says at most 3, then you start from 0, 1, 2, 3. So we're looking for the probability of at least 3. Probability of at least 3. At least 3 means the probability of 3 plus probability of 4 plus probability of 5 plus probability of 6. 6. Yeah. So that will give us equals to 3. It says to use binomial table. We're not going to use table because I want to show you how to do this with Excel. So I'm going to take you to the Excel. Let me write them down. N is 6. P is 0.45. And Q is we don't need Q because we're going to use Excel, so we don't need Q. It's already factored in Excel. X equals 3, 4, 5, and because it says probability of at least 3. So let's go and put it in Excel, and then we can put them in. Say here, N equals 6. P equals 0.45. So X, for X's, I'm gonna put it right here. Have X will be, I'm gonna start from 0. I like to get all of them because it says here, it says that the a survey, if 6 teenagers were selected. So I want to go from if you remember when I wrote the definition of this binomial binomial, I said that it goes from 0 to the last value of n. So for this one, you're gonna go from, I want to get the answer from 0 all the way to 6, since since the number of teenagers selected is 6. From there, I can figure out the probability of at least 3. Okay. So I come to Excel. I have it here: 0, 1, 2, 3, 4, 5, 6. So you have PX. Let's get our PS now. PX. Okay. So that we have let's get the first one equal binom that this to show up. Numbers is from 0, right? Comma, trials 6 times, so about 6, comma, probability is 0.45. Not cumulative, false. Okay. See now? Then I have it for all of them all the way to 6. Now, but what we are looking for is this: the probability of at least 3. At least 3 equal. So let me expand that section. So that's what you're looking for. At least 3. At least 3, like I said in the formula, it means probability of 3, 4, 5, and 6, which means that the probability of at least 3 equals the probability of 3. Click on that. See the 3 right here, plus that of 4, plus that of 5, plus that of 6. And then you press the enter key, you get your answer right away. Okay. If you ask you at most, that means you're going to add from 1, 2, 3. You know, at most 3 means 3 or less. Now, so that's how you do it. Any question on this one?
No, so far so good.
Okay,
It's
good.
better
Right?
doing it through Excel, which I like.
You could prefer the Excel method, right?
Yes.
Okay, good. So now you can ask us, you can be asked, let me just type the answer we got in Excel, and that would be 0.558. Okay. 0.558. 0.558. Now, for the mean variance and standard deviation of a normal binomial distribution, the mean is which we represent with mu is n times p. Variance is n times p times q, and the standard deviation is square root of variance. Let's see this. So suppose we are given these values. Say find the mean, the variance, and the standard deviation for this. He said n is 100, p is 0.75. So let's solve this one, the first one. I mean, that one is easy. Just put the numbers in. N is 100. Then mean p is 0.75, and then q equals 1 minus p, always 1 minus p, which means 1 minus 0.75. You can double check this. Anyway, I can just check it with the calculator. 1 minus 0.75. Okay, 1 minus 0.75. 1 minus 0.75. 0.25. Okay, 0.25. Okay, and then so that the mean, which is this number here, the mean, okay, so will be n times p. So we have mean as have this mean equals n times p, which is our n is 100 times p is 0.75. 100 times that will give us 75. The variance, this is for the mean. Let me put this here, mean. Variance equals, and for variance we use delta symbol for variance. Delta squared. Delta squared equals just this, equals n times p times q, okay, which is 100 times 75, 0.75 times Q, which is 0.25. That gives us the variance. So we have it as hundreds, 100 times 0.75. Oh, excuse me. 0.75, 0.75 times 0.25. Oh, sorry, 25. 18.75. 18.75. 18.75. Then standard deviation is square root of the variance. And our variance is 18.75. So it won't allow me to put the formula for standard deviation here. So I'm going to put it on this workbook. I have standard deviation, deviation equals the square root of 0.8 the variance, okay, which is the square root of 18.75, okay, which is square root of that. Okay, square root of 18.75, which is 4.33. 4.33. 4.33. So let me copy this and then paste it here. Okay, paste it at our main workbook. Save. So I'm gonna unbold all this. Any question on this one?
No, not so far.
So it's the same method that we use to, to the application of it. It says that the statistical bulletin published by the Metropolitan Life Insurance Company reported that 2% of all American births result in twins. If a random sample of 8,000 births is taken, find the mean, variance, and the standard deviation of the number of births that result in twins. So how many of them were selected? It's 8,000 births. So our n equals 8,000 births. Then our, actually small n, you have P, say 2% of them. So P is 2%, which is 0.02. And then Q is 1 minus P, 1 minus 0.02, which is 0.98, right? Am I right?
Yes.
So now, so to make it faster, we can just put it in Excel and then put in it simplified the process 8,000 for n. So I'm gonna just type mean here. Mean variance. Okay, and standard deviation. That's what they're looking for with this information. So let me go and put Excel to make it faster for us. Okay. All right, we have this. So you have n is 8,000. 8,000. P is, we got 0.02. And then Q is Q equals 0.98. Then so we can now, with this we can get our mean. Mean variance and standard deviation. Standard deviation. Okay. All right. If you remember the formula I posted for this, to save time, I'm gonna just copy it from here. Okay. Okay. Just gonna copy it from all of them from here, and then, oh, excuse me, sorry. Go to Excel. You can see the Excel, right? Can
Yes,
you?
I can see it.
Oh, I missed everything up. Okay. Okay. Yep, right here. Mean is n times p. So mean equals and n is 8,000 times is the asterisk sign. P is right here. Press the enter key. Get 160 bets result to twins. Variance equals n times p times q, which is n times p times q. Yeah, enter key. Get me this. And standard deviation is the square root of variance. Put equal sign SQRT is square root. Okay, it pops out here. Double click and then click on variance. Close it and press the enter key. See, give us all the answers. So I got mean is 160. Variance is 156.8. Standard deviation is 12.5. So let's go and put them in for our answers here. So we have our answers here. Okay, mean is 160. Variance is 156.8. Standard deviation is 12.5. Okay. So with this, we can now look at next type of probability distribution. It's the one that is called the Poisson distribution. Poisson distribution. So this, it is so called because it was derived by a French mathematician, Simeon Denis Poisson. That's why they get that name. Introduced it in 1837. That's how you get the name Poisson distribution. Now, we use the Poisson distribution when we are counting the number of times an event happens in a fixed interval. And we normally use it for rare event that occurs, rare events. Like the COVID-19 occurred, and then it was big. It was a big deal. Then nobody hears of it anymore. This kind of thing might occur 1 in 10 years, 1 in 20. So those kind of rare events, we use it. For example, we can use Poisson distribution to model the number of car accidents at a particular intersection in a month. Number of emails a person receives per hour. Well, that one may not be rare event. Okay. And so on and so forth. So the properties of the Poisson distribution is a discrete probability distribution of a random variable x that have satisfied this condition. The experiment consists of counting the number of times x an event occurred in a given interval. And that interval can be time, it can be area, it can be volume. And the probability of the event occurring is the same for each interval. And the third property is that number of occurrences in one interval is independent of number of occurrences in other intervals. And for computing the Poisson distribution, Poisson probability, we use, I want to show you the formula we use. Make it 16 here. To compute it, we use this formula here. Px equals, should I have seen this? Mu to the power x, then e to the power negative mu divided by x factorial, where this small e represents the number 2.71823. It's an irrational number. It's a constant given for this kind of distribution. Then for this symbol mu represents the mean number of occurrences. Like I said earlier, the formula might look like a monster, but actually when you use it, you discover that it's not that bad. Now we'll be using Excel to do this, but let me show you, this is the equation we're gonna solve here. Okay. Say the mean number of accidents per month at a certain intersection is 3. What is the probability that in any given 4 months, any given month, 4 accidents will occur at this intersection? So that means any given month, X is 4, and mean, you say that mean is 3. Say the mean number of accidents at that intersection per month is 3. So mean is 3. And this E part, remember I said that it is a constant for this game, part of the formula is 2.71828. When you plug it into the formula, you get this. The formula is mu to the power x, e raised to the power negative mu by x factorial. Let me write it down so we can put it in the calculator. You can see it. Px equals mu to the power x, e to the power negative mu over x factorial. Okay. Now, we can do it. In this case, our x is 4. So our s is 4. So you gotta be, give me 1 minute. Yeah, 4. So that's why I got for mu is 3 to the power 4 times 2.71. 3 to the power 4 times 2.71828 raised to the power negative mu, which is right here. Negative mu, that is mean of 3. Negative 3 over x factorial, which is right there. This is x factorial right here, which is 4 factorial. So let's put it on the calculator and then I'll show you, and then we can I will show you how to get it with the calculator, and that will be for that. We can now go to the final section. So we got right here, we got 3 to the power 4, 3 raised to the power 4, actually. Okay, times, in parentheses, 2.71828 raised to the power negative 3, negative 3 divided by 4 factorial. 4 factorial. That's it. Let me see if I can function here. 4 factorial is right here. See, it's factorial right there. Give us 0.168. Okay, so giving us 0.168. Okay, so you can see right here. Now you can see I can put it on the calculator Excel to show you how we got this. Let me write again. Write this down. I got x is 4, mu is 3, e is 2.71828. Now, this is the Excel formula we use for this to find Poisson distribution. That's the formula right here. Poisson, of course, you gotta put the equal sign first before you type it in. Poisson, yeah. Then S, comma, mu, comma, cumulative. Then for cumulative, and for this part, use false if you want the probability of exactly X, like we have on this one, exactly 4, we're looking for. Okay, but it says, what is the probability that in any given month, 4 accidents? See? So, but if you're looking for the cumulative, then use true. So let us put in Excel. Yeah, we're almost done. For the Poisson, we have that X is 4. Then mu, let me put in mu, character for mu. Mu, I think I have to copy it from that. Okay, I see it here. Mu. Okay, good. Close it. I got mu is 3. Then E. Oh, small e. I think you can get if direct from here. Equals exponential ESP top C for 1. That's got to give us the E. See, 2.718. Now, so the probability we are talking about PX, P for 4. Okay. Equals. Now let us get it from here. Equals. Remember the formula is this. Poisson. Let me copy it from here so we can put it right there. Poisson dot this. So I'm gonna put excuse me, sorry. I'm gonna put a box here so you can text box so you can put okay, let me see. Insert shapes. Yeah, let me put a text box here so you can text it here. Poisson. See? Make it a little bit bigger and bold it. Good. So that's the formula right there. So that we have Poisson. So you have equals Poisson dot this. It pops out, double click. X is this, click on that comma. Mean is 3, comma. The cumulative? No, not cumulative. We're looking for 1. Yeah. Okay. You didn't even ask for the E. Okay. So false for cumulative. False. Okay. And press the enter key. See, 0.168. Which is the same thing as what we have here, 0.168. You know, when you use the formula. 0.168. Do you have any question on this one?
No.
Okay. All right, that's how you get the Poisson. So let's do the last one. Last one is the normal distribution. Many variables, continuous variables like height, temperature, cholesterol. They have this distribution that have a bell-shaped distribution. So we call them the normal distribution, bell-shaped distribution, or Gaussian distribution. You know, Gaussian distribution, named after the German mathematician that derived the equation. So the normal distribution is actually a continuous, symmetric, bell-shaped distribution of a variable. And like when I was saying bell-shaped, I mean this. See? So it's symmetric. That means half of this is equal to the. You can literally fold this on that. Just like our body, half of this is the same as the other half. So let's look at the properties. The normal range of example of variable that can be modeled using normal distribution. And that will give you an idea what I'm talking about here. Normal range of systolic blood pressure is 110 to 140. If it's less than that, it's low pressure. If higher than that, which is not normal, it's bigger than that, is higher blood pressure, which is not normal. The normal interval for a person's triglycerides from 30 to 200 milligram per deciliter. If it's bigger than that, not normal. If it's less than that, not normal. Average birth weight for baby, for babies, is 6 to 9 pounds. Less than 6 pounds, underweight, which is not normal. And above 9 pounds, overweight, which is again not. So that will give you an idea of what we use normal distribution to model. And then, so we can this leads us to the properties of normal distribution. One is that a normal distribution curve is bell-shaped, shaped like a bell. You can see right here, shaped like a bell. Okay. The mean, median, and mode are equal and are located at the center of the distribution right here. See, mean, median, and mode. You can see the mean, median, mode equal. A normal distribution is unimodal. It has only one mode. The tallest part of it is the mode. Okay. The curve is symmetric about the mean. Yes, like I said, you can literally fold this side into that side, so it's symmetric. The curve is continuous, and that is, there's no gaps. Yes, because continuous, no gap. The curve never touches the x-axis. Of course, it gets closer to the x-axis, but never touches it, so that it is asymptotic in mass, Total area under the normal distribution curve is equal to 1 or 100%. So this side is 0.5, this side is 0.5. When you add them together, you get 1, which is 100%. Okay, let's see how to get the area under the normal curve. And then we can look at some examples. Okay, probabilities. So we have to the left of Z. Now, to do that, there are some formulas, except formulas you can use. I have them here. I see them here. For this one, like the one we're looking for, it says for this one wants us to standardize. Okay, this is for required. Okay, this one's for standard area. Okay, in 1 minute. You can use table, or you can use the Excel to get these areas, like here. So requires, I say find area between zeros. This one says to the left of 1.76. So let me put in Excel. 1.76. Z equal 1.76. So the area for that area will be area. When I say area, I mean probability actually. Area equals for this one, but it says to the left of Z equals 1.76. So I mean, it's same as saying Z less than 1.76. That's what it means. And for that, you can see what you use for that. Z less than, see, norm.s.dist. Then type is Z and type 1. Because for the standard normal distribution, the mean is 0. And the standard deviation is 1. So for this one, we're going to have norm.dist equals norm.s.dist. It will pop out. See, the area is, the Z value is this, comma, cumulative, just type 1. Okay. Then that will give you the area, 0.9605, 0.9608. So that's how you get, basically how you get, it depends on the, I didn't show, you didn't see this one, right?
Yes.
Okay. So I type this, you have, asking us for this area here. This is again. Yeah, 1.76 to the left, I think I need to copy that in so that it will be easier for us to navigate through them. So let's see the area we need. What we need is this one here for some of those ones. I'll copy this. Standardize Z. Copy this. And paste it right there. So it will be easier for us instead of going back and forth. Yeah, this is why we are. I'm going to put it right here. So now, see, to the left of Z, 1.76 means Z less than small z. Yeah, Z less than that. So you can put that in. This is the formula here, norm.s.dist. Z, comma 1. So I'm going to put it here. I put 1.76 there. See, you can see this one, right? So you have area now become equals norm dot s dot this is it will pop out. Double click on it. Double click. Okay, click on that. We say Z. Click on it, comma, and then 1. Okay, if it's less than. Yep, let's give it that. 0.09608. Now, if it is greater than, you do a different thing. Let's say it's greater than area. Okay. Now, if you look at the second one here, it says greater than, say to the right of, say, that means greater than. For that, you're gonna use this. Greater than 1 minus num.dist dot s, num.s.dist. Yep. So I'm gonna show you what you're gonna get for that. So if you're on the right, you're gonna use equal that 1 minus num dot s dot dist. Pops out. Click on that, close it, and put the enter key. Give it, excuse me, sorry. I didn't put everything. Click on that. This here, comma, then put 1 again. And enter key. See, give me that. So that's how you find the area. And it's the same as finding the probability. For example, when you look at this one here, for example, it says this one, it says, I'm gonna copy this down. Okay, we have it here already. Say find the probabilities for each of these using standard normal distribution curve. The first one says, let's say part A, this like solutions. Part A says what we have there is P of this. Okay, let's copy this, paste it here. Okay, for this type, what do you do? I mean, actually, matter of fact, there are 2 ways you can do it. You can draw the curve and use the table. But if you're using Excel, Excel will simplify the voting. So this one, the formula we use, Excel formula we use this one. See, because there are 2 of them. See, from between 0 and that. I'm going to show you. Okay. Between 0 and that. So that means you're going to use between Z1 and Z2. That means 0 and this. In that case, get this one first, num.this, .s, .this for this one, and get for this one 0, and then subtract them. So let us put them in. First of all, we have P0. Let's say that we have our Z1. Here, Z1, okay, is 0. And Z2 is Z1, okay, equals 0. Z2 equals, yeah, we have 1.45. 1.45. I don't know if you're seeing this. 1.45 right here. It's right here. So now I'm going to insert this so you can see it from here. Insert a box, text box in Excel for this. So I didn't put it right there. Excel, this text box. And then paste it right there. All right, let's see, copy that question. That is this one here. Yeah. Yeah, okay, good. All right. Make sure you're seeing this. Good. This is one we're about to solve. So I'm gonna put it right there. Take you to Excel and paste it there. It's what I was trying to solve. Then make it big. So now, to solve that, we need this formula here. Want us to look at the formula while we solve it. And the formula is, a set formula is right here. Okay, so I'm gonna paste it under it in Excel. Paste it there. So let's put it in. So that the probability of we're looking for PX, the probability now we're looking for will now become equals, start on this one, num dot this, sorry, num dot s dot this. Double click, it shows up saying cumulative. So you have Z2, you can see Z2, which is this one here, comma 1, okay, minus num dot this, so num dot s, num dot this, double click, says Z1, comma 1. Z1 is 0, comma 1. Close it and press the enter key to give us answer right away. Okay. So I'm going to show you the formula for all of them. Let's do one more example and we're done. The one they ask question on this, apply question. Are you still there?
Yes.
And I know you're tired. Don't worry, we're finishing. Okay.
Yes, I'm still here.
The application of normal distribution. Standard. This is the formula we use. Z equals to S minus mean over standard deviation, where S represents the data value, Z is the standard score, mu is the mean, and delta is the standard deviation. But like I said, however, we'll be using Excel to do this. And the Excel formula for that, I'm going to show you in a minute. When we have to save the standardization methods, I'm going to use this one here. I'm going to copy it and paste it under so that we can solve this question, and then you can use it to practice other questions. So it's right here. I'm going to paste it under this question right here. This is under here. So I'll paste it here. Okay, good. Now this is the question we want to solve. The application of standard normal distribution. Okay, make it 18 so you can see it. Say the monthly utility bills in a city are normally distributed with a mean of 100 and the standard deviation of 12. A utility bill is randomly selected. Find the probability that the bill is less than $70. B, find the probability that the bill is between $90 and $120. C, find the probability that the utility bill is more than $140. So to solve this question, I want to move it to next page so we have enough room to solve it and move everything down. Okay. So they told us that the mean is $100. So I'm going to put mean as $100. This here. Mean is $100. So I'm going to make it big. Make it 18. Mean is $100, and the standard deviation is 12. Which means that the delta is 12. So I insert delta equals 12. So with that, we can begin our work. Part A says that find the probability that the utility bill is less than 70. So for part A, X is 70. Remember that for a standard normal distribution, the mean is 0 and the standard deviation is 1. I think there's a place I wrote that definition down. Say, the standard, make sure I've seen this, just 1 minute. Okay, it said the standard normal distribution is a normal distribution that has a mean of 0 and the standard deviation of 1. See? So now we have that in mind when we solve this part A. And to solve part A, the Excel formula we need is this. It says, find the probability that the utility is less than. That's the key right here. Less than. Okay. And for that, it says here, PS less than X. So we're going to use this. So I'm going to put it under it so you can see it. That's what we're going to use to solve. Instead of using the formula, this formula here, instead of using that, you can just use this one to get the answer right away. So I'm going to paste it here. So you can see the formula we're using. So, and that will give us our answer we are looking for. So I'm going to put it in Excel, put these numbers in Excel. I got a mean of, make sure you're seeing this before I go to Excel. Okay. So I got a mean of 100 and standard deviation of 12, and our X is 70, because it says that find the probability that the bill is less than $70. So taking you to Excel, we have that the mean equals okay. Same. Mean equals $100. And then standard deviation, okay, standard deviation equals we have 12. And then X equals $70. But that's what it says. So that the probability that the mean is less than X, less than $70. Let's see what you can see. Less than $70. Okay, less than 70 will be given as follows. Now I'm gonna put the formula here so we can. First of all, let me put a text box where I can put the formula. Put the formula right here. Now I'm gonna take you to the Word document to get the formula. The formula is right here. It's this one here. And then take you to Excel and put it right there. I'll make it big, bold, and bigger so you can see it clearly. That's the formula right here. So we apply it to this question. Less than $70. You still here? Hello?
Yes.
Okay, that's I want to show, because this is once you can be able to understand this, you can figure out the rest by using the other formulas. That's why I want to show you this. So say X less than X, num dot this, see, and then put all these numbers which are here. So equals num dot this, it pops out, double click, and X is right here. Click on it, comma. The mean is 100, comma. The standard deviation is 12, comma. And it says 1. It means type in 1. Then press the enter key to give you an answer right away. 0.0061. You have any question on this?
No.
So now we just apply this to all of them. Like if it says like this one that says find the probability that it is between 90 and 120. So let me just put the answer we got for this one first. We got the probability of P of X greater than, sorry, less than 90, right? Less than $70. We got the answer as from the Excel. We got the answer as 0.0062. Right there. 0.0062. Now, for the part B, which will be the last example we do tonight, then you can I'll show you where the formulas are. You can just start applying using them, you know, and they will help you a lot. Part B says, remember the mean is still the same, and standard deviation is still the same. Just the only thing that changes is the X value. Here we have two X's, say between 90 and 120. That means our S1 equals 90 and X2 equals 120. That's what it says. Yeah, let me adjust this. Let me adjust this one as well. Okay. So you have between 90 and 120. So 90 and 120. Now for that, the formula we'll be using is this one here, between S1 and X2. So I'm gonna copy it, and then, you know, you're gonna be using it for this. Let's say probability of S1 less than S1 is 90. 90 less than X, then less than 120 equal. So now I'm gonna go to the Excel file and put these numbers in, and then we'll calculate it. The mean is 100, standard deviation is 12, S1 is 90, X2 is 120. Let's go and put it in and get our answer right away. So you have it for here. We have, let me copy this side so that it would save us time for the mean right there. Okay. Then we have X1, okay, which is 90, and X2, which is 120. So that the probability we're looking for, probability of 90, yeah, less than, I'm not used less than here before, so we're gonna less than, okay, X, yeah, I'm gonna put it twice. Okay, now close it. Less than X, less than 120, okay, equal. That's what we're looking for. To find it, we're gonna be using this formula here. Make it again. This is the formula we're using. Yeah, this is what we're using here. To go to the Excel and put it right there. Okay, I'm gonna insert text box that will contain the formula. I'm gonna paste the formula right there. Make it bold and 16. It should be good. Up 16. We're gonna make it 14 then. Yep, that's the formula we're using. So for that, we use this formula to get it. That'll give us the answer right away. Equals, get this part. Num dot dist pops out. Double, oh, excuse me. My error. Okay, let's start all over again. Equals num dot dist. Double click. X is this one here. So we're gonna start with on X2. So 120, comma, the mean of hundreds, comma, and the standard deviation of 12, comma, then 1, close it, minus, repeat the same thing, num dot, this, you're repeating it for 90, pops out, the mean of x of 90, comma, the mean of 100, comma, the standard deviation of 12, comma, and 1 again. That will give you your answer right away. Press the enter key. 0.7498. So this is the last example. You have any question before we round up? Any question?
Not right now, no.
Okay. So let me show you where this list of the from last is. Let me just type this in the answer points. We got 0.7499 because 0.7499. So you got 0.7499. Okay. I'm still on Excel. 0.7499. So you have right down here where we are 0.7499. Now this is where the list of the formulas are located. So you can, if you want, okay, let me put all of them here. So you can, depend on the way the question is framed, you can use any of this in Excel to solve it. And that's the list right there. Yeah. And with that, I think our lecture today is ended. So like I said, I'm going to make a video for the topic we're doing this week and upload it. And I'm going to upload this one as well so that you guys can watch it. And that's the end.
All right. Thank you so much.
Well, you're welcome. You guys have a nice night.
You as well.
Okay, bye-bye.
Bye.
Thanks. Have a good night. Bye.
You too.